Hi, it's Rachel O'Hare, and this is Quideo number 3. Sorry about that. I just spilled water on it at the very last second, but let's go ahead and start with the basic question. For part A of the basic question, it asked, what is the probability that the vehicle you choose has any color other than the 6 listed? Now, this comes from the chart here, given with the probability of each color of car for vehicles made in North America. So for this, we found the probability of any other color than the ones that were listed. So I simply added up the totals of the probabilities and subtracted it from 1, since it has to equal 1, and whatever the difference was is how many cars don't fit into a category, and there are therefore any color other than the ones listed, and that is 29.5%. Part B asked, what is the probability that a randomly chosen vehicle is either silver or white? Now this is a union, so we're going to follow the additional rule and add the probabilities. So before we look at what my work said, this is just a refresher of the additional rule. So it's only for events that can't occur because of one another. And so we're just going to add the probabilities together like this. So we added silver and white, which is 0.176 plus 0.172, and we got 34.8%. And part C asked, when choosing 2 vehicles at random, what is the probability that both are silver or both are white? So this is not asking if one is silver and one is white. It's asking if both cars are silver or both cars are white. So we're going to add the probabilities of the cars like this. So we're going to multiply the probability of it being silver for both cars and add it to the same for the white. And then from that, we got 6.06% is the probability of that occurring. Alright, we're going to go ahead and look at the advanced question. Sorry for the smudge. Thankfully, we can still read what's important. So, part A asks what the explanatory and response variables are. So, with this, I said that the explanatory variable was the taking of antioxidants or just the antioxidants themselves, and the response variable was the rate of colon cancer, because when we look at the question, it says that people who eat lots of fruits and vegetables have lower rates of colon cancer, and those who eat little of these than those who eat little of these foods. And this is based on the antioxidants that are in those fruits and vegetables. So they're saying they want to find out if the antioxidants are what causes the lower rates of colon cancer. Alright, part B of this question asks us to outline the design. So here I've listed just how I would set up the experiment. The participants needed to be divided into 4 groups in order to have enough people to take each of the treatments. So I just took the total number, 865, and divided it by 4. And so that means that 216 people will be in each group. And each group is given one of these 4 treatments for 4 years every day. And then they are collected again at the end of the year, at the end of the 4 years, to see if there's any correlation with the antioxidants and their rates of colon cancer. Part C asks us to choose the first 5 subjects for the beta-carotene group. So we went into the table B at the front of our textbook, and we picked these numbers, 731, 253, 304, 470, and 296. Now, if these numbers, they were obviously going to have to be 3 digits, but if they were anything higher than the total number of 865, it would have been disregarded, just as like a double would have been disregarded, or repeat. And part E of the question asks about some working variables that could be possible to explain the correlation between the rates of colon cancer and the antioxidants or fruits and vegetables consumed. And so I said that overall higher consumption of fruits and vegetables could be the result of a healthier diet and therefore a healthier lifestyle, which would already reduce your risk of cancer, but also Family history of colon cancer is also another factor that could contribute to your rate of colon cancer, which is how the question worded that. And lastly, the AP question. So here it says for the antibiotics that were being chosen for the ear infections, Part A is known to effectively cure the infection 60% of the time, where it costs $50, and antibiotic B is known to cure for 90% of the time for ear infections and costs $80. And so it presents two plans, and plan 1 is the use of antibiotic A first, and then if it's not effective, using B, and then plan 2 is vice versa. So B goes first, and if it doesn't work, it's antibiotic A. So the first part of the question asked what the probability was of being cured by both plans. So I went through and I just plugged it into a basic formula. It's the probability of like A plus the probability of not A times B, and so I got 96%. And then I did the same for plan 2, and ended up with the same answer even though I plugged in different variables. So the probability of being cured on both of the treatments is 96%, which is also very high, and it is the same. So either way you go, you have a high chance of being cured of your ear infection. And then part B asked what the cost per child was on each plan. And so this I just pulled the cost for the treatment plan, multiplied by the probability, and then you add it to the total cost of the treatment plan, which is going to be $130 because it covers both medications, and then times the probability of not, in this case, not A, which is going to be 0.4. And so for plan 1, I got $82. And then for plan 2, I did the same thing. I just plugged in the probability of B occurring, and then of not B, and then the price of the original treatment, just treatment B, and then the total cost. And here I got $85. So in plan C, it asks which one you would recommend. And since the probability of being cured is the same for both treatments, I said I would recommend plan 1 since it was cheaper. And so from a financial standpoint, that one would be seen as more beneficial. And that's it.